Hi students, this is Shivkrishna, Chemistry faculty under Narayana Group. Students, today I am going to discuss the JEE mains question paper which was held on April 4th, 2024 Shift 1 examination paper. Students, the questions which are appearing on my screen are completely student memory based. So any ambiguity is there, these will be cleared later. Let us see students one by one. Yes, the first question is the EMF of the electrode at 25 degrees centigrade is 0 in pure water, then pressure of hydrogen in bar. Let us see student, standard hydrogen electrode 2H plus 2 electron gives rise hydrogen. If you write the EMF of the cell, E cell is equal to minus 0.059 by 2 log of pressure of hydrogen by H plus whole square. Student, actually he given hydrogen electrode at 25 degrees is 0. Already E cell is 0 is equal to minus 0.059 by 2 log of pressure of hydrogen by concentration of H plus whole square. Now you see student, the total value becomes 0, which is equal to log of the pressure of hydrogen by H plus concentration square. We can write 0 as log 1 log of the pressure of hydrogen by H plus concentration square. Then pressure of hydrogen is equal to H plus concentration square. Already they given that H plus concentration in water 10 to the power of minus 7 whole square at pure water at 25 degrees centigrade. Then the pressure of hydrogen is 10 power minus 14 bar. Therefore, the answer for the first question is 10 power minus 14, option 1. Now, let us go for the second question, student. For which of the following element only one oxidation state is possible? Let us see. The given elements are scandium, cobalt, nickel and iron. You know student, cobalt exhibits +2, +3 and +4. Likely nickel exhibits +2, +3 as well as +4. Iron exhibits +2, +3 and +6. Okay now students, along with +4. The only element which exhibit a single oxidation state is scandium, that is +3. So the answer should be 1 for the given question. Now let us go for the next question, student. Among the following, decreasing order of basic strength will be. Simply, the basic strength is inversely proportional to acidic strength. That means you please convert the given every anion into its acidic form. That means OH minus as H2O, H minus as H2, HCOO minus as HCOOH, acetate ion as acetic acid, and alkoxide and as alcohol. First of all, I have written the acidic forms, that is protonated forms of the given anion. Now you write the acidic strength order. Among the given acids, the acidic strength order, formic acid is more acidic than acetic acid, which is more acidic than water, which is more acidic than alcohol, and which is more acidic than hydrogen. This is the acidic strength of the acids. Now our given anions are the conjugative bases of my acids. Then the conjugative bases, formate ion, acetate ion, OH minus, alkoxide and hydride ion. Now, according to Bromstead-Lowry theory, a strong acid produces weak conjugative base. So, according to the order, formic acid is the strong acid, then formate is the weak conjugative base. According to the order, hydrogen is the weakest acid, then H minus should be the strongest base. Therefore, the given order correctly matched is H minus is 2 and alkoxide is 5 and OH minus is 1 and acetate ion is 4 and HCOO minus ion is 3. So the correct order is 2, 5, 1, 4, 3. The correct match for the given answer, given question is 3. So according to the logic, a strongest acid can give weakest conjugative base. So the given anions I treated as a conjugative basis. So I have written protonated from the given conjugative basis. Then I wrote acidic strength of these acids. Then I found the basic strength of the given conjugative bases. This is the way we can express the answer. Now go for the next question, student. We are given the following graph between the P and T. That rho is the density they given. You know, students, according to the ideal gas equation, PV equal to nRT, then PV equal to weight by gram molecular weight into R into T. Then P is equal to gram molecular weight is equal to weight by volume into R into T. Then Pm, that I am treating gram molecular weight as M, is equal to density into R into T. Here P is nothing but pressure, M is nothing but gram molecular weight of the gas, density D, and R gas constant, and T is the temperature. Then D is equal to what I can write? Otherwise Pm by RT, or you can write this also like this: P is equal to dr by m whole into t. Then it looks like y equal to mx. Therefore, the slope m is belong directly proportional to dr by m. That means the slope value depends upon the density and gas constant and molecular weight. Here that is, therefore, where is the density is more, automatically the slope of the line will be more. So according to the answer, rho 1 is the highest slope, and then D2 and D3. So answer should be 1, because the slope depends upon the density of the gas also according to the given. Now let us go for the next, student. Which of the following have maximum dipole momentum? Let us see. Ammonia is a pyramidal structure. The dipole momentum of the lone pair is upside, and all the dipoles of each bond also be in the upside direction only. So in the given molecule, the bond moment and the lone pair moment both are in the same direction. If you go for the NF3, student, is also be pyramidal. Here also the lone pair momentum is upside, but fluorine is more electronegative than nitrogen. That's why the bond moments are in the downside. So the resultant momentum of bond momentum is downside and the lone pair momentum is upside. And if you go for the next molecule, PF5, PF5 is a trigonal bipyramidal. Everybody knows that. That is a symmetrical structure. Therefore, dipole momentum of the molecule is 0. And if you go for the PCl5, in the same way, is also be trigonal bipyramidal, and also symmetrical structure, regular and symmetrical structure. Therefore, mu equal to 0. So that ammonia and NF3 only dipole momentum is not equal to 0. Among these two, ammonia has more than that of NF3, since bond moment as well as the lone pair moment both are in the same direction. But in NF3, lone pair moment and the bond moment are in opposite direction, though the highest, so the highest dipole momentum is for ammonia. So the answer 1 is the correct one. Now let us go for the next question, student. Question number 6. The question in that aldehyde function is there as well as ketonic function is there. The given reagent is a zinc amalgam and HCl, which is also called Clemmensen reduction. In Clemmensen reduction, what happened? The carbonyl function group become the CH2. So the answer should be this is and this is. Therefore, answer is 2. I think it is the easier question. Now, question number 7. Which of the following is the correct order of first ionization enthalpy? The given elements are second group elements, the second period elements, sorry, that is beryllium, boron, nitrogen, oxygen, fluorine. Generally, these are the second period elements. So, among these, if you want to write ionization energy, that is 2s2, this is 2p1, this is 2p3, and this is 2p4, and this is 2p5. 2s2, 2p5. In general, left to right ionization energy increases because effective nuclear charge increases and the size decreases. But some exceptions are there. What are that? Beryllium has more than that of boron. Since the 2s electron are paired electron, S has more penetration power than P. And in P, boron, the unpaired electron is present. Therefore, boron is lesser than that of beryllium. And if you go for left to right, effective nuclear charge is increases. That is why ionization energy also be increases. But nitrogen has more than that of oxygen due to off-filled electronic configuration. Off-filled or fully filled degenerate orbitals are stable. That is why nitrogen has stable electron configuration rather than oxygen. And if you go for nitrogen to fluorine, again effective nuclear charge dominates. So in beryllium and nitrogen is the exception. Therefore, answer should be 2. Now let us go for the next question, student. Yes, question number 8. Aldol condensation is caused by acidity of alpha hydrogen. Yes, what is the condition to exhibit aldol condensation? There must be one sp3 alpha hydrogen to the carbonyl. Yes, students. Now this alpha hydrogen gets tautomerizes in the presence of base. Like this. Now the base will come and takes this. Now here it is going to attack another carbonyl. So is going to prefer like this. This is the mechanism involved in aldol condensation. The first step is the replacement of alpha hydrogen. That is, alpha hydrogen to the carbonyl is more acidic. That is the reason why it readily participates in the reaction. So statement 1 is the correct one. Cross aldol is not possible between benzaldehyde and acetaldehyde. Just now we discussed either aldol or cross aldol. In the carbonyl, minimum it should have one at least minimum or at least one sp3ch should be present. Yes, in my acetaldehyde alpha sp3ch is present, so there will be a crossed aldol condensation possible. But he said it is wrong. So both statement 1 is correct and statement 2 is incorrect. So statement 1 is correct and 2 is the incorrect one. Now let us go for the next question. 9th, select the correct structure of L-glucose. L-glucose is nothing but mirror image of D-glucose. Let us see the D-glucose structure. I am considering each HOH like this. Two R, 3S, 4R, and 5R hexahydroxy hexanol. Mirror image for this. I am taking as a arrow mark. So the match for the given option is, if it is a D glucose and this is a L glucose. So the correct option is 2, I think. Is it correct? Then next, go for the next one. 10th one. Decreasing order of field strength of the following ligands will be. Here the ligand strength order we have seen in the CFT, crystal field splitting theory. We have seen the order of ligand strength. According to that, carbonyl is more than that of Cn minus, is more than that of water, is more than that of chloride. I think this is the correct order of what is the ligand strength. So the given option matches to the 1. Yes or no? Now let us go for the next question. Calculate the molarity of NaCl if 5.85 gram of NaCl is dissolved in 500 ml of solution. It is basic formula. Molarity is equal to weight of the solute by gram molecular weight of the solute into 1000 by V in milliliter. Molarity we have to find out. Weight they given is 5.85 and the gram molecular weight of NaCl 23 plus 35.5, it is a 58.5 grams into 1000 by, that is 500. Now you see 2 times and it is 0.1 time. Therefore the answer is 0.2 m, molarity of the solution. Now let us go for the next question. Which of the following does not give Lassine test? Lassine test to be positive means urea, NH2, C double bond O, NH2, and azobenzene, you see. Next, hydrazine, phenylhydrazine. Lysine extract generally given for extra element identification, that is nitrogen, halogen, sulfur and phosphorus. To identify nitrogen, what is required? Sodium plus carbon and nitrogen combines and produces NaCN. Nitrogen in the given organic compound combined with sodium produces a sodium cyanide. This lysine extract to be identify nitrogen. In lysine extract to be identify nitrogen, there should be formation of NaCN. To form NaCN, there must be requirement of carbon. So in hydrazine, there is no carbon. That is why hydrazine cannot give lysine extract. Now let us go for the next question. Among the following species that have one unpaired electron, you can easily see that carbon, nitrogen minus, that is nitrogen plus nitrogen, carbon plus nitrogen, 6 plus 7 plus 1, that is 14 electron. Let us go for O2 minus 2. Okay, that is 8 plus 8 plus 2, that is 18 electrons. You see O2 plus, that is 8 plus 8 plus minus 1, 17 electron. So you see student, in O2 plus, in O2 plus its pi star anti-bonding molecular orbital as one unpaired electron. Therefore O2 plus should be the answer. Now let us go for the next. For a given reaction, alcoholic KOH upon heating, what happened? It is the reagent to remove HBr. alcoholic KOH causes dehydrobromination, followed by HBr. It is the addition by Markovnikov rule. According to that, negative part of the addendum goes to the more substituted or more stable carbocation. So it should be like this. This is the B. Already given is P. So relation between the P and B. P is a 1 bromo 2 phenyl ethane and B is a 1 bromo 1 phenyl ethane. These two are positional isomer together. Position of the substituent only different. That's how we can call that as a positional isomers. Let us go for the next question. From the given data, the enthalpy of hydrogenation of ethene in kilojoules per mole. Ethene, the structure of ethene. Hydrogenation means addition of hydrogen, which gives ethane. Therefore, enthalpy of reaction, this energy released is called enthalpy of reaction. According to that, it is the sum of bond energy of reactants minus bond energy of product. Then automatically we can write this is one C double bond C is there, one C double bond C bond energy is there. Along with there are 4 CH bond energies in the reactant side. At the same time, 6 CH bond energies on the right side. So the leftover is 2 CH bond energy we will write on the right side. Otherwise, we can write here also 4 CH bond energy plus 1 HH bond energy minus of 1 CC bond energy plus 6 CH bond energy. Then we are getting, after substituting, C double bond C bond energy is 600 kilojoules per mole. Here 4 CH and here is 6 CH, and HH bond energy they given as 400 kilojoules per mole minus of CC bond energy they given as 350 kilojoules minus of 2 into what is that? Remaining 2 CH bond energy 410 kilojoules per mole. The overall answer become minus 170 kilojoules per mole. Therefore, the suitable answer is 1. Simply, we have to see the bond energy of reactant and the bond energy of product. Next question. Find out the wavelength of the photon having the frequency equal to nu is equal to C lambda. Then nu is equal, lambda is equal to frequency is inversely proportional to wavelength. Then nu is equal to C by lambda. Then what is asking you? Wavelength. Then wavelength is equal to C by nu. Already C is nothing but 3 into 10 to the power of 8 meter per second. And frequency is the given 9 into 10 to the power of 2 second inverse. That is, okay, 3 by 9, 1 by 3. That is 1 by 3 is equal to 0.33 into 10 to the power of 6. That is 3.33 into 10 to the power of 5 meter. Frequency is always inversely proportional to wavelength. Then nu equal to C by lambda, lambda equal to C by nu. Now let us go for the next question. Why ammonium chloride is added before ammonium hydroxide for the precipitation of Fe plus 3 ion? Okay, the KSP of group 3 hydroxide is lesser than group 4 and group 6. The KSP of hydroxide is lesser than group 4 and group 6. If I use high concentration of hydroxide instead of group 3 hydroxide, group 4 and group 6 hydroxide will be precipitate rather than group 3. So to maintain less concentration of hydroxide ion, we are using ammonium chloride. What happens here, you see? Ammonium hydroxide is a weak electrolyte, that is NH4 plus and OH minus. Here ammonium chloride is a strong electrolyte which completely dissociates, which causes a common ion effect. Because of the common ion effect, the equilibrium goes back and the concentration of hydroxide and what happened? Decreases. Due to that, only group 3 cations only precipitate as hydroxide rather than group 4 and 6. That is the reason why. That means indirectly to decrease the OH minus ion concentration, we are adding ammonium chloride, which causes common ion effect to the ammonium hydroxide dissociation. Now let us, that is 19th, nitrobenzene. Nitrobenzene, the NO2 group is a minus R group as well as minus I. So the correct match is minus R. Aniline. Aniline is a NH2 is a strong activating group and that is plus R. How to identify mean? NO2. Yes, whenever atom attached to more electronegative element by multiple bond, it can act as a minus R group. Whenever an atom or group attached to the conjugation having the lone pair with octet configuration act as a plus R group. Here addition of H plus, addition of H plus. In the presence of H plus, the pi electrons are moved to one of the bonded atom. This is called electromeric effect. Because it is temporary effect, it occurs only at the time of attacking agent. So here the must be, here the pi electrons are moved to where is the attacking reagent is attached, at the same place the pi electrons are moved, that is called plus electromeric effect. You see here attacking agent goes to the carbonyl carbon because oxygen negative, carbon is positive. Now here the pi electron are moved to other than the attacking agent attached center, other than the attached center, attacking agent attached center, then that is called minus electromeric effect. Since these two reactions only occur at the time of attacking agent, so for the option B, A, C, D, B, A, C, D. Therefore, the correct option is 1. Let us go for the next. Which of the following is not possible major product? HI addition as Markovnikov rule. Correct answer. NaNO2HX, that is a which causes diazonium salt. It is a diazotization reaction. Diazotization reaction. In the diazotization reaction, readily, because aliphatic diazonium salts are unstable, readily forms carbocation. This hydrogen shifted to here because carbocation gets a rearrangement. Hydride ion shift occur, forms stable carbocation. Now on this solvent water attacks and we are getting alcohol as the major product rather than nitroalkane. Therefore, the answer should be 2 because he said not possible major product. You see another also HBr addition, Markovnikov addition, bromine CCl4, cyclic bromonium cation, followed by that we are getting dibromoalkane. So the correct option for the given question is second because that is the only given wrong product. How many of the following compounds are sp3 hybridized? Generally, for a given one, how to identify? you take as one of the formula number of surrounding atoms plus half into group number of central atom minus sum of valency of all the surrounding atoms, 3 2s are 6, plus if any negative charge is there, anionic is there, addition, cation is subtraction, 8 minus 6, that is 2, 3 plus 1, that is equal to 4. It is called steric number. Whenever the steric number is 4, it must be sp3 hybridization. Surrounding atoms plus half into group number of central atom minus sum of valency of surrounding atom and charge on it. Then we are getting the steric number 4. Therefore, ClO3 minus is a sp3 hybridized. Cl tetrahedron I am writing because one of the lone pair is present. Surrounding atoms are 3. He said -1 and the remaining is balanced by placing double bond. Therefore, it is sp3 hybridized with pyramidal shape. Likely ClO2 also sp3 hybridized. Ammonia is also sp3 hybridized, but NO2 it is a bent shaped with unpaired electron. Therefore, it is not a sp3 hybridized. Therefore, for the given question, the answer should be 3. Now let us go for the next question. 22. Total number of structural isomers possible for a compound with a molecular formula C7H16R. First, whenever they are given, you try to calculate double bond equivalence, degree of unsaturation or hydrogen deficiency index. That value become number of carbons minus number of hydrogens by 2 plus number of halogen by 2 minus halogen by 2 plus 1. Therefore, double bond equivalence I got is 0. That means the given must be, there is no degree of unsaturation. What is that? There is no double bond or the ring. It must be open chain saturated one. It also matches with CnH2n plus 2. So we are having the possibility alkane. 1, 2, 3, 4, 5, 6, 7. This is one possibility. I am replacing one carbon. I want to keep either here, either here. If I place here, it become again the same. I want to remove this time 2 carbons. One I want to place adjacent together. I want to place at 2, 3 position like this. And you can write this as ethyl. And you can write this as the 2 methyls are be like this. I can write one more chance. As like this. 3 methyls I am replacing as like this. Let us see how many chances. 1, 2, 3, 4, 5, 6, 7, 8, and one more is also possible. That is 1, 1 methyl, 1, 3 methyl, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. We are writing. Yes. We can write like this also. The 2 methyl groups on the same. This is the 9th. The total number of possible isomer are 9. These are the possible isomer for the given C7H16. Now let us go for the next. The de Broglie wavelength of an electron in the 4th orbit of hydrogen atom. According to de Broglie theory, which coincide with the Bohr, 2 pi r equal to n lambda. According to Bohr theory, r equal to 0.529 n square by z is nothing but a naught into n square by z angstroms is equal to n lambda. So this n gets cancelled. Okay, now you want to only what is that lambda value 2 into pi into a naught into n is fourth orbit, and it is said hydrogen atom, that is lambda in angstroms. Therefore answer should be 8 pi a naught, 8 pi a naught angstrom. The answer should be in angstrom, but he was not mentioned, so answer should be 8. Now let us go for the next question. 50 ml of KMnO4 solution is used for titration with 20 ml of 2M oxalic acid solution in acidic medium. The molarity of KMnO4 solution. Here KMnO4 act as a oxidizing agent, and the oxalic acid undergo what is that oxidation, and it acts as a reducing agent. It is a redox reaction, that is KMnO4 plus H2C2O4 in the presence of acidic medium, that become Mn plus 2 plus, here 2 carbons are there, that means it become 2CO2. Here the change in number of electrons 2 minus, here charge on manganese is 7, 2 minus 7, n factor is equal to 5. Here you see each carbon is plus 4, here each carbon is plus 3. Therefore 2 into 4 minus of 2 into 3, overall change is 2, n factor is 2. So it is a KMnO4 versus oxalic acid redox titration. According to that, number of milliequivalents of KMnO4 is equal to number of milliequivalents of oxalic acid. Number of milliequivalents of KMnO4 is molarity into n factor into volume in milliliter is equal to molarity into n factor into volume in milliliter. Molarity we have to find out. N factor is 5, volume is 50 ml they given, molarity of oxalic acid given to, n factor is also 2, and volume in milliliter is 20. So after calculating that, I got that answer 32 into 10 to the power of minus 2 m molarity. That is 0.32 we will get 8 by 25. That is nothing but 32 into 10 power minus 5. Therefore answer should be 32. This is the way we have to go for that. Question number 25. A solution having the non-volatile solute in water shows a elevation in boiling point, that is delta TB is equal to 2 degrees centigrade. Find out the vapor pressure of the solution. Generally, to find out the vapor pressure of the solution mean P naught minus Ps by P naught is equal to X2 according to Raoult's law for a solid in liquid solution. So first of all, I have to find out what is that, Nana? X2. That means mole fraction of the solute. What is the data they given? Delta 2B they given, Kb value they given, and P naught value, that is 760 mm of Hg also they given. So to do this, I want what is that, Nana? X2. So according to that, data Tb is equal to Kb into m, okay, into I. But already is said non-volatile solute, and it doesn't undergo any neither dissociation nor association. Then delta Tb, that is 2 is equal to 0.52 into m. We will get the m value. M value is roughly 3.84, like that I got. After getting m value, what is that a molarity versus mole fraction? That is mole fraction of the solute is equal to molality by molality plus 55.5. After substituting, I got the answer 0.06, like that. After getting that P naught value, P naught is how much? They given 760 minus of Ps by 760 is equal to 0.06. Then I can get the solution vapor pressure is equal to roughly 710.86 like that, which nearly equal to 711. This is the way we have to solve the problem. Actually, the thing here is, first we have to find out molality of the solution from the elevation in boiling point. Later, we have to find out mole fraction. Mole fraction of the mole fraction versus molality. Here, aqueous solution whose molarity is equal to 55.5. So, X2 versus molality is like this. After calculating X2, I have substituted in Raoult's law. We are getting vapor pressure of the solution. Now, let us go for the next question, student. MnO2, KOH and O2. This is pyrolusite. That means preparation of KMnO4. Here, MnO2 when reacted with KOH passed by oxygen, we are getting, that is K2MnO4 as A. A disproportionate into B and C. K2MnO4 disproportionation in the acidic medium as KMnO4 plus of MnO2 plus of H2O, that is B and C. Okay, find the sum of magnetic momentum of B and C. Here B is MnO4 minus 1, that is manganese 7, that is D0, that is magnetic momentum is 0 because the unpaired electrons are no. Here MnO2, in MnO2 the charge of the manganese is plus 4, that is 3d5 4s2, it become 3d 3 4s0 because of Mn plus 2, sorry Mn plus 4. So the number of unpaired electrons are 3. The magnetic momentum is equal to under root of n into n plus 2 Bohr magneton. That is 3 unpaired electrons are there. Root that is roughly 3.84 Bohr magneton will come. Therefore, the answer should become, what is that? 4. Because the answer is above 3 point something. So 3.86 plus of 0, 3.86. That is answer should be 4. Next, go for the next question, student. How many of the following coordination compound have even number of unpaired electron? In the first complex, VH2O taken 6 plus 2. Here, water is a weak field ligand, scandium, titanium, vanadium. That is 3d3. That is why it has 3 unpaired electron. Since water is a weak field ligand, we can write as a T2Z3 and EZ0. And here second complex FeH2O taken 6 plus 2. Here also water acts as a weak field ligand, Fe plus 2, that is 3d6 and 4s2, that is 3d6. We can write that as a T2Z 4 and EZ2. There are total number of 4 unpaired electron. Let us go for the next one. CuH2O taken 6 plus 2. Here copper having plus 2, that is always 3d9. 3d9 mean T2Z6 and EZ3. Again, one unpaired electron present. Now let us go for nickel plus 2. Here also water as a weak field ligand, that is 3d8 and 4s0, that is T2Z and Eg, that is octahedral complex, that is 1 2 3 4 5 6 7 8, that is 2 unpaired electron is present. Now let us go for chromium, last one. Chromium plus 2, 3d4. Here weak field ligand T2Z 4 EZ0, sorry T2Z3 and EZ1, because weak field ligand T2Z3 and EZ1, 4 unpaired electron is present. So 1 unpaired electron, 3 unpaired electron. Except these two, in all of them there is a even number of unpaired electrons. So 1, that is 2 and 3. There are out of the 5, 2 only are unpaired electron. You see 3d4 I can write as T2Z3 and EZ4. Therefore here is also 4 unpaired electron. All these are even number and even number. So answer should be 3 for the given question. Except this and except this, remaining all having even number of unpaired electrons. Let us go for the next question. Consider the following reaction. Actually, here is the equilibrium reaction, that is reversible reaction. The overall rate constant also they given. First, forward reaction and backward reaction, activation energy is also given, and overall activation energy also given. He asked to find out B to C activation energy. They given K is equal to K1 into K2 by K3. Then automatically we can write EA is equal to EA1 plus of EA2 minus of EA3. EA is equal to 400 kilojoules per mole. EA1 is equal to 300 kilojoules per mole. That is EA2 is equal to 200 kilojoules per mole and EA3. Then EA3 is equal to 500 minus of 400, that is equal to 100 kilojoules per mole. Okay, the asked answer also in kilojoules per mole, therefore answer should be 100. Now let us go for the next question. X gram of ethyl amine on reaction with NaNO2 and HCl produces 2.24 liters of nitrogen at NTP. The value of 2x will be, see here student, NaNO2 plus HCl, which produces first HNO2. Now ethyl amine C2H5NH2 reacts with HNO2, produces C2H5OH plus of nitrogen plus H2O. Yes or no? Now from this what you understand that nitrogen, 1 mole of ethylamine produces 1 mole of nitrogen, but they given that just 2.24 liters of nitrogen, that is number of moles of nitrogen produced equal to 2.24 by 22.4 given volume by gram molar volume. I got that 0.1 mole. Therefore the given amine is 0.1 mole. Therefore the weight, the value of 2x is asking you in grams. So moles of ethyl amine is equal to 0.1. The weight of ethyl amine is equal to 44 in 45 into 0.1 is molecular weight is 45. It should be 4.5, but the answer given is 2x, that is 4.5 into 2. Therefore answer become 9. Therefore the answer for the given question is 9. Thank you very much, students.